Okay guys, just a quick mini lesson on naming and formula writing for ionic and covalent compounds. First of all, let's talk about ionic compounds. You need to know that an ionic compound is between a metal and a non-metal. So before you even think about writing a name or a formula, you need to look and make sure that there is a metal to know that you're doing it this way with ionic. In terms of naming, it's pretty straightforward. What you do is you name the metal, and then you name the non-metal, but you end it in "ide." So for example, if you see MgCl2, you would know that Mg, or you could look up on the periodic table that Mg is magnesium, and Cl is chlorine, so we would change chlorine to chloride. Some of the nonmetals have kind of funky ways that they cut off at the end: fluorine, fluoride, iodine, iodide. You can look up a list of that or ask if you have any questions about that. When it comes to naming something like a polyatomic, this might seem a little bit tricky, but really it just comes down to memorizing. So when you see MgCO3, we recognize Mg as magnesium, and you have to have studied those polyatomic ions to recognize CO3 as carbonate. So you would simply name magnesium and then just carbonate. We don't do any change the polyatomic suffix to "ide." It's just carbonate. Carbonate is carbonate, and there's nothing we change about that. The other tricky thing here is there are a couple metals that we need to do something a little bit extra for. Those four metals, for your reference, are lead, copper, tin, and iron. All four of those metals are, for examples, there's actually more than that, but those are the four that we need to know can have more than one possible charge. So when you are naming, again, this is only for naming, not for formula writing, rather than just naming this, like we see that Pb is lead, and we know that I is iodine, so iodide, we need to know to put that Roman numeral in there to tell us what the charge of the lead is. Now, I know some of us are having trouble with this, so here's the way I want you to think about it. You look here, you go, okay, I've got one lead. So there's one lead in this molecule, and this 4 here tells me there are 4 iodines. So I have 1, 2, 3, 4 iodines. From the periodic table, you know that iodine wants to gain 1 electron, so each iodine has a charge of -1. And think about this for a second. What's the grand total there then? If I have 4 iodines, each -1, that means the grand total there is -4. That means that the lead here on this side, in order to cancel out and be neutral, you'll note, and I'm going to use a highlighter here, you'll note there's no charge written there, PbI4, there's no charge. That tells us this is a neutral compound, which means all the positives and negatives are canceling each other out. So hopefully you can see that we can deduce that this Pb must be +4, so that +4 and -4 all add up to 0. Okay? If there were 2 leads over here as a side note, so if it was like Pb, Pb to our 4 iodines, and we figured out that all 4 iodines were -4, then each lead would have to be +2, but that would be a different compound. That would be for Pb2I4, which actually doesn't exist, so that might be a bad example, but it works for the analogy for the charges. So anyways, going back to our original example, so I'm going to kind of scribble this out here so we don't get confused. The PbI4, we deduced that that charge of that lead was 4, so we would put lead 4 iodide. Okay? These are pretty much the 3 types of examples for, again, we're talking about naming ionic compounds. Now, what about formula writing? To write formulas, oops, get rid of that. To write formulas for ionic compounds, the big idea is you need to find the charge of each ion, okay, and sometimes that does mean a polyatomic, sorry, I ran out of space, and then you need to balance the charges. Okay, so a couple examples. First, a simple one. If I told you something like aluminum, let's do fluoride. Okay, if you saw this on a test or quiz, you'd go, okay, aluminum I know is +3, fluoride's -1. how many aluminums, how many fluorides do I need? Because we know aluminum and we know fluoride. But the real question is, well, what goes here? How many aluminums to how many fluorides? If it was 1 to 1, that'd be -3 and +1, because one aluminum has a charge of +3, one fluoride has a charge of -1. And that obviously would not equal 0. That would actually equal +2. So that can't be right. So if I add another -1, well, then that's a total of 3 -1 -1. That would be a total of +1. Well, that can't be right. What if I have another -1? 3 -1 -1 -1. That does add up to 0. Now, remember, this is the aluminums, and these are the fluorines. So I end up with seeing that I need 1 aluminum, and you don't need to put a subscript if there's 1, and fluorine, we need 3. So that would be aluminum fluoride. If you see something like this, you see something like copper to, say, phosphide. Okay, again, phosphide, not phosphate. That's phosphide. You'd go, okay, copper's +2. Phosphide is just phosphorus in the periodic table. That's -3. And you kind of do that same process. Okay, I've got +2, and I've got -3. Now, one of the tricks I gave everyone in class, I said, think about common multiples. The lowest common multiple of 2 and 3 is 6. That tells you I'm going to need a total of +6 and -6. Because 2 and 3 don't go into each other, but they both go into 6. So if I look at my +2, I've got, okay, well, I can see that I'm going to need 3 +2 charges to equal +6, and I'm going to need 2 -3 charges to equal -6. And remember, these represent the coppers, and these represent the phosphides. So I end up with Cu3P2. That would be copper 2 phosphide. Remember that the 2 here tells you the charge. It does not tell you the number of coppers. Okay, we still have to balance charges to do that. And I think, let's do one with a polyatomic. So if I did one with a polyatomic where I gave you the name, let's do zinc cyanide. Okay, now don't forget that zinc and silver are 2 that you just need to know. They only have 1 charge. We don't need Roman numerals for them. Zinc will always be +2. Silver will always be +1. Okay, remember that little diagonal: aluminum, zinc, silver, +3, +2, +1. Sorry, those marks might be confusing. And then cyanide is Cn-1. Again, you got to have that memorized. If you don't have it memorized, you're not going to be able to move forward with this problem. So we go, okay, zinc's +2, cyanide's -1. Hopefully you can see that if I have 2 -1s, and if I have 2 cyanides, that will cancel out my 1, sorry, not copper, my 1 zinc. So I've got ZnCN for cyanide, and then a 2. But you can see that kind of looks confusing because that looks like I'm putting 2 nitrogens. So I'm going to throw a parentheses on there, and that would be zinc cyanide. Okay? Sorry, doing the teacher thing. I'm pausing to see if there's questions, and I'm realizing I'm talking to a computer, so have a good laugh at me for that. So just real quick, though, that is all for, if you remember, I'm going to scroll back up. That is all for ionic compounds. You'll note we did not use any prefixes ever. The other type of compound will be a covalent compound. Okay, covalent is if there is a nonmetal bonded to a nonmetal. These will never, ever, ever have metals in them. And the way that you name them is simply you add the prefixes to indicate how many. So if I see something like this, N2O, I would first check, okay, nitrogen's not a metal, oxygen's not a metal, okay, I could use prefixes. And I would look at it, okay, well, there's 2 nitrogens. The prefix for 2 is di, and then I put nitrogen. Dinitrogen tells me 2 nitrogens. And then there's only 1 oxygen here, right? Again, we don't put the 1, it's implied. So mon, the prefix for 1 is mono, but with monoxide, they kind of blend the O's together, so it's just monoxide. Dinitrogen monoxide. If you see something like, I'm just going to make something up, C2H5, okay, that would be dicarbon. 5 is, you got to, I mean, you have to memorize the prefixes, but pentahydride. Okay, we still ended in "ide." Okay, so we change oxygen to oxide, hydrogen to hydride, what those prefixes tell you. And this is all for if you were naming covalent compounds. Okay, lastly, if you're going to formula write, pretty straightforward. If you see something like tetracarbon non-anhydride. You go C because you see carbon. 4 is tetra. Non is 9, and you see hydrogen. Okay, and again, that's not actually a compound. I'm just making stuff up for the sake of examples. Okay, hopefully that was helpful. Just real quick here at the end, I'm actually going to give you a little quiz. I'm going to give you a couple things to name. And you can pause the video if you like and see if you can identify. So most of them will be ionic, just because I know that that's what's trickier, that's what we need more time with. And I'm actually going to just make them all naming ones. We'll do some formula writing ones too. So let me put some over here. Let me scroll down. So if I said ammonium acetate, and then we'll do zinc nitrate. Oh, we just did one. Sorry. Let's do zinc. We love this one. Permanganate. Okay, so pause really quick. See if you can do those as practice, and I'll write the answers in. First one would be magnesium. And we recognize that last part is sulfate. Second one, we see copper. Sorry, my phone is beeping. Nitrate. And this is one that we need to know what the copper's charge is. So we know we're going to need a Roman numeral here. Nitrate's -1, so we know that copper must be +1 because there's only one of each. Copper 1 nitrate. This one here, we recognize that this one is covalent. This is actually the only covalent on the page. So we'd have sulfur. Remember, we dropped mono on the first one. Dioxide. Next one, we see silver, hydroxide. Okay, and then some of the formula writing ones. Ammonia is +1, acetate's -1, so it's just one of each. Ammonium is NH4, acetate is C2H3O2, or you could have written NH4CH3COO. Zinc permanganate, zinc is +2, permanganate is -1, so you'd have ZnMnO4 with a 2 at the end. Hopefully that helps. For those of you that are actually in my chem class right now, don't forget that our quiz is Tuesday, worth 40 points. But hopefully this helps. Hopefully this gets you back on track. Email me if you have any questions. Good luck.